Hello, my name is Tom Marcos and this is my solo project for this class. The game that I decided to develop was a game that's designed after Vampire Survivors. And I'm not sure if you're familiar with that game, but the goal of that game is a kind of a time-based survival game where you acquire different weapons as you kill enemies and time goes on. The enemies get harder and you get randomized rewards and whatnot. My game has a similar spin to that, similar mechanics, although I decided to make it round based. And here, let me just show you a showcase of that game. So, so you can see one thing about this game is you do not actually control your weapons. Rather, you have the weapons that are attached to a timer that trigger over time as you play this game. You have 10 enemies that come after you, and as you kill them, you have this XP bar on the top. When you get enough XP, you get a level up, and the level ups usually consist of different things that you can get for your character, whatever that's like more strength or heal HP or unlock an axe, a bow. We have three different weapons. We have a bow, we have an axe, and we have the standard sword that the character starts with. So let me go ahead and select one, which is for my bow in here. You get these rewards every single time the XP bar fills up, and I had made it so it scales up and it becomes harder and harder to actually get these rewards. You can see on the HUD in here, you have a timer in here that just tells you how many seconds you've been here for. You have a round indicator in here that tells you which round you currently are. I made the threshold to be 20 enemies that you have to kill in order to advance the round. And then you have all the things in here that indicate your HP, indicate your levels, and indicate the amount of enemies that you have killed. These walls over here, they're actual objects, so you cannot go through them, but the enemies can. And this game does get kind of harder as the enemies pile up. I did not make it too hard, however. I can make it much worse. So you only get 20 enemies at most chasing after you. I can easily make it so it's more than that. So you see the other rewards in here. Let's activate the axe, which is our third weapon. The axe, as you can see, it travels on this arc that might be a little bit too fast, but it's still an arc. And it does a lot of damage in here. And the enemies, we have three different types of enemies. We have the regular skeletons, we have the skeletons with red eyes, and we have the red skeletons. They all have different attributes, different strengths. Their healths are different. The amount of XP that they give is different. And so does the damage that they deal to you. It's kind of hard to actually talk while focusing with this. But over time, they do become harder. Their health and the strength does scale over time. I could make it so they could chase you faster, but I think this is good enough as is. But you do get upgrades over time, but they do become much harder to get. It does use an exponential model. Let's decrease the sword delay here. It does use an exponential model to calculate how much XP you need to the next level up. So it does become pretty hard by the time you level up. Like quite a couple of times, like by the 10th time you level up, it's going to be quite hard. You can see the HP bars that are floating on top of the enemies, and that's actually a representation of their current health and their max health. That bar that's behind them, that black bar, is actually their max health. It takes the width as a value of their max health, and the red is the actual health that they have in that given moment. I made it also too that you do not get hit too often in a single second. So I can just walk in. Let me increase the sword strength. I can just walk in here. And you notice that I only take damage over couple of seconds. It is a second cooldown when I get hit. You can see it by the hit indicators that I have added to the enemies. But you can see that they get hit. You can hear the sounds of the weapons, and as the music is playing in the background, that is a sound object that's playing my music. And there's two sound objects. One that's playing the music, and the other one that's playing sound effects, since they cannot really overlap. You noticing here how much harder it's becoming to kill these enemies. Their health is going up. I actually never lasted this long in this game. But look, I died right there. It's a simple game over screen. It tells me what round I died on, and it tells me that I took down 96 enemies with me. But that's the goal of the game, and I can go back in and just... Really the goal of the game is just to last as much as I can. I do have some tiles set up in here. And I did make it sure so you actually don't get past these tile over here, because I wanted the enemies to just be able to come from me to me without me actually seeing the spawns. They do come from far away, and I had set a distance where they actually do spawn from quite away from the quite far away from the player. But I don't want to actually see the enemies popping in front of me, so I made it so they spawn quite far away and they kind of just start walking to you at the same time. They can go through those walls easily, and that's the point of it. This game can be kind of memory intensive, depending on the amount of enemies that are on the screen, and I did make collision checking going on in here, so they don't just clump up. It's a single entity. But that's pretty much it for the game, and yeah, your goal of the game is just to survive as long as you can. But we can just now just go over what the code for this looks like. So we have quite a bit of coding here, and we have all these classes, and there can be way more classes to this. But due to, again, some time constraints, I need to actually allocate some time in order for me to encapsulate some things better, and actually just separate code from the main game.java class file. There's way too much going on in here that can easily place into other classes, but given the amount of time, I want to have to do that later on. Let me just make sure this is recording. Okay, so we can go through the basics. So first of all, we do have our game base that we have made in class, and the same thing from the rec.class over here. Most of it is really code that we learned from class. We do have to we were saying how we use the game base class in across all our games, and it works just fine for me for establishing my screen width and my height, and getting all my key listeners going down in here and establishing the threats, so it executes in the game loop while it's while making it sleep. It's mostly stuff that's been taken from class and I built up from here. And then we do have our painters that do happen off screen, just so we don't have that flickering going on, even though we do get some flickering as the animations load in. That's not something I have implemented, loading on the all the sprites before the game actually starts. But we do have our base class that we did in the class, really just taken from there. And we have also our rectangle class. That's again kind of the same thing. We establish our rec class with the different dimensions of the rectangle, and along the methods that I use are the ones to actually make the enemies chase you. If comparing their x's and their y's and moving their x's and their y's to a speed of 3. If I set it to 4 or 2, 2 was too slow, 4 was too fast. So I made it around 3 that it would chase me with. We have our methods. Again, this is stuff that we went over class to go up, go down, go left, and go right. I use that to actually move the characters around. And we do have the push by method that actually comes pretty handy for the collisions. I use that to make the collisions happen for the walls and make the collisions happen for the enemies when they get too closed. And that's of course detected with the overlap and they came from below and above. I use the overlap to see if any of the weapons actually overlap with any of the enemies and if I overlap with any of the walls. They came from above, below, left, and right methods are within a class also do come pretty handy for collision checking and again for wall checking. So I can actually use this push by method into the correct direction. And the contains method, I kind of just use it in the same manner I would use overlap because some of my weapons might just be big and actually contain the enemy rather than overlap with it in the borders that the rectangles make. The resize method that we have made in class, I actually wasn't able to use it. I was planning on using it in the future because one of the rewards I was going to make into this game was actually being able to resize the sprite so you could have a bigger sword. I didn't implement this as yet, but this will be in the future revisions of this game. And then we have our draw method in here that we use to draw our rectangles. We do also implement the camera X and the camera Y for parallax scrolling. Again, it's lots of context taken from class, but we can go on ahead and actually see what we built on from this. So there's a lot of variables that I have declared in here. And yeah, I can definitely go through them. But I made some variables in here that allow me to track time. There's multiple things that do require me to track time, be it just frame counting for damage or for weapon activations or anything else. I track my enemies in here. I track how many enemies I have spawned in the frame. This is for the collision checking. I only want to check for so many collisions going on at once because I'm not doing that every frame. Uh, this is a weapons activated variable that actually not using right now. One of the design changes in this game was actually that you were only allowed to have a certain amount of weapons, which is supposed to be somewhere around 5 or 6. But I have yet to implement more weapons. I only have 3 so far, so if at some point I go past that number, I wanted to cap the amount of weapons that the player can get. So you can't just have a whole arsenal, you can only be so strong. This is the variables for setting cam X and cam Y for parallax scrolling. This tracks my rounds numbers, this tracks whatever my round ends. I made some variables in here to just check how many enemies I killed in a round, so I can either progress the round or just have it as a stat that I'm tracking in there. This will track my level depending on how much XP I have obtained. The skill level XP needed will be using this base level XP needed, and it will scale up as the amount of levels that you obtain go up, and you will see this later in the code. This is a Boolean flag that I made just to draw the level up screen that you saw in there. Whether this is true, that it's going to trigger that screen. So this is some weapon triggers in here that they use multiple things in here. By default, you start with the sword, and you have animation flags in each one of these weapons, and these are used to indicate whether an animation is happening or not, and many things happen based on that, whether I'm actually drawing the thing on the screen or whether I'm calculating speeds for the weapons. It will be very reliant on this animating flagging here. You have the same things in here. There's some animations and position timers that I use to see where these weapons are usually thrown should be giving a time, giving a certain frame that they pass by. I'm not sure if I did use the position timer for the X, but we'll see down there in the code. What else? So they activate. I'm actually supposed to be passives in here. They're actually supposed to be items that will increase the stats for you, and you will upgrade those items. But I kind of just took a shortcut and just let me just upgrade the stats instead. So this is why that was written here. At the beginning, I do want to make my player in here, which I give it all this different. I give it all these different attributes in here. So the tile map that I made around down here, these are the dimensions that I created for this tile map over here. And you want this player to be placed right in the middle of it, otherwise the parallax scrolling will be just kind of thrown off. So you want the player to be right around in the middle of the screen. Oh, well, not really on the screen. It's actually not for parallax scrolling, but rather for me just positioning myself in the middle of the tile map. The parallax scrolling is actually not related to this. Sorry about that. But I want the player to spawn somewhere around here. I don't want him to spawn all the way somewhere around here because I can't go through these walls over here. So this is really the area that you should be spawning. That's really what this is for. So now you have your variables. These are for me for just to declare my sword, bow, and axe of objects, and I put them in a list so I can manipulate them later on. These are even more timers for the weapons. These are lists for the enemies that we'll use to manipulate enemies as a whole and to be able to add enemies one by one to a currently spawned list of enemies, and I will go up in detail about that. I will store my rewards in here, and I will display my rewards in this array in here. This is the size for each one of the tiles in here, and we have 4 different images to pick from the resources, which is usually tile 1 through 4. So now we have our walls in here. This is a volume that you use to trigger whether these walls over here are done building or not. And now we can go with the in-game looping here. So for the in-game loop, it is very long. This is a very long class file. And again, things can definitely be broken up. But so far it works. So there's a check that happens at the beginning of the game loop, which is to see if the level up is waiting. And we have our array here for level up choices. And we use the key listener 1 through 2 and 3 to pick one of those rewards that you saw on the screen earlier on. This choose rewards is a method later down there that will enable us to pick our reward depending on the number that we choose, which should be right over here. So this choose reward method actually grabs the indexes and makes sure that the number that you're pressing is 0 to the length of the display choices, which should be 3. So if I'm pressing number 4, number 5, or number 6, it is not doing anything. I want you to press the correct numbers for the index. This will pick the index from that list. You're not supposed to pick anything from outside of that list. I'm not listening to any other indexes outside of that. Once you do pick that index that represents your reward in here, you do turn off the level up waiting in here. And this is a flag that I made to randomize the level up rewards, because down here I actually set up the rewards over here, and I set it up from 0 to 6. You can see what each one of the rewards actually do in here. And we will go over the respective classes in here, but there's a reward class right over here that we'll show you in a bit that takes 2 arguments, and one of them is a string argument and the other one is a lambda function that I can give it so I can execute it and run it with a runnable method or library, I guess you would call it that, in Java. It was a pretty neat way for me to just have this function into a single line and be able to just return it into another and have it executed. But I will go more into detail in a bit for that, but let's go back to here. So assuming that you actually do finish your picking your reward in here, now I will scale up the XP that you actually get, which is this is the exponential model that I used. 1.3 to the current level that you have. Current level being 1, 2, 3, and 4, and we are going to convert this into an int, since we are using ints in this game. But let's look at the rewards actually. So, how about we look at the reward class, since we are talking about rewards right now. So, for the reward class is super simple. So there's two attributes that this class has, and that's a name and a runnable chosen reward. I looked up about ways that can make the rewards happen, and I read about runnables. And runnables were pretty interesting because they allowed me to just get a runnable in here and use the .run for the runnable. And I could just be able to just execute whatever I passed then into this function as a runnable. So instead of me calling some other different function or just making methods to run different functions, I can just pass it in directly in here as an argument. See over here, for example, if I want to pass the string, which will be the naming here, I pass val active true as a lambda function that returns nothing in here. Well, it's a void, but I mean not void, but doesn't take any arguments. I execute this function and I pass it in here as a runnable. Runnables, let me check where I actually do run these over here. Let's see. Right. So when we go back to the chosen reward method in here, you can see that when we go into that array that has the choices that are being displayed, we can use that run on the runnable. So it actually runs that lambda function. So that's why it's pretty handy to write it this way for all these different rewards in here. But how are actually the rewards calculated and put into an array in here? Well, over here, I actually implement some of the ways that you load in that array here, and it's using the math library for random numbers. I need to look this up again. It can be kind of tough to navigate this. Oh, it's right over here. All right, so this also assumes that your player is not dead going on over here, and that you had to hit the amount of XP that you need to level up in here. So I make an array in here that shows you your chosen numbers in here, and I put in as a -1 and 1 and 1, just three numbers, because it's three rewards that we're showing, and this will represent that we're not using these. We're not using -1. It just represents being empty. So now I iterated through this array here, and I make a random reward number here that I generate using a random number generator in here. So the goal on this code is that I generate three different numbers, and then I check if any of these numbers, right over here, I check if these numbers are actually unique. And have I chosen these numbers before? Have they been generated? I don't want to pick two 2s at the same time because I don't want to give you the same reward. So this is what this is for. If the numbers are the same, just get out of the loop, and eventually we'll just come back in here because we need to somehow break out of the while loop in here. I'll make another check in here, and that is to check if any of the rewards is a 1 or a 2 if the bow is active or the axe is active. And the reason is because the bow and the axe are one-time rewards. I don't want those rewards to come in again. So there's an extra check in here to see if those arrays for 1 and 2, as shown down in here, 1 and 2, if they already have been picked before in the past, which they trigger a flag. I mean, they don't. Yeah, they do trigger a flag when you make them active. They do not need to show up again. They only take space, so it checks if they are active. Now, if you somehow ended up getting these 3 numbers differently, then you just go back in here and actually break out of the while loop in here. So this is how you get a unique number going on in here for this this array of 3. Once we have actually our chosen numbers, that's our indexes that we're going to use to select each one of those items in the arrays and display them later over there. Each time we do add one of those rewards, we increment this rewards randomized number just so we can actually get out of this if over here. This will only happen if we have not randomized all the numbers in here. So that's why we incremented, and that's why we make our cap over 3. And eventually we do draw our level up in here. We use our pen and we write using color white. You use our dimensions of our screens to just write level up. So I want this to be somewhere in the middle of the screen, so that's why I divide the screen divided by 2 in here. And this is just a Y value for this. And now we iterate over the display choices, and we display each one of those choices as we iterate over each one of them. And we draw them. We take these. The reason why this is I plus 1 is because we are going to write 1, 2, and 3. We're not going to write 0, 1, 2, 0, and 1, 2. That's not how you want it to be presented. And again, I want this to be somewhere in the middle of the screen with some leeway in here. This will move it down a little bit with the eye. Because you can see that the list shows 1, 2, and 3, and they go down horizontally. This is a way that you can make it go down horizontally. Just multiply the I by 100 and add 300 of it. But that's pretty much it that comes to the rewards. So let's go back up. And you can see, let's see. So this is the check for level up waiting, and here we're not getting past here unless this is turned off. This is very helpful for actually making everything else just stop. If we have a level up waiting, that's how we achieved all the enemies and everything going on in the background to just be frozen when there is a level up waiting in here. And at the beginning of the game loop, we establish our time. This is going to be used for so many things. We want to keep this running in the game loop because we want our time to be updated in every frame. And for some of those functions, I do also want them to be in seconds. So I converted into seconds because since this is milliseconds, so I divided by 100. I also wanted to start at 0 because the current time in the system is counted as the current time in the system now. It doesn't count as 0. So I subtract that. I subtract that from start time so we can actually start counting down from 0 in this current time seconds. Over here I made a null check for player just to check that the player is not dead, and if it's dead then we trigger that game over screen. Anything over here will not happen unless the player is not marked as null. I have to do the same thing for the draw method, otherwise you're gonna get a lot of errors in the game. So at the beginning, we also generated random numbers in here, and this is used for spawn rates in here. You will see more about that later, but I made a weighted spawn rate. You actually can see very close over here where it is. Oh, it's right here. So usually the math random numbers will pick any number between 0.0 and 1.0. So over here, I made it weighted by basically saying that any number that happens between 0 and 1, if it's anything over 0.6, that's which is 60% chance of happening, I'll return a 1. Anything above 0.85, 25 chance, I'll return a 2, and the same logic applies for 3. I use these numbers to adjust the spawn rates for each one of those enemies down here. So what we check the result that we got from here, and if it's 1, we spawn the regular skeleton. If it's 2, we spawn the skeleton that has red eyes, and if it's 3, we spawn our hotter skeleton, which is the red skeleton. And you can see in here that they have different attributes because of the skeleton class. The skeleton class over here extends the enemy class. I gave it some names in here, and we have our template for the skeleton, which is just health, strength, and max health. These can all be adjusted over here. We are actually passing in the values for health and strength and and max health. All these attributes we pass in depending on the skeleton we have, and one of them is also XP. You can see that tougher skeletons give us more XP, and these also climb up depending on the round number that we have. The same exponential number that I use for the EXP. So these become harder as the rounds come by, and you saw that in our little demo. That the health bars were going up and they were becoming harder to kill. As for the spawns, we have the spawns right over here, and I made it so they need to spawn at these distances. So they need to spawn at least 2,000 of whatever value what that will be, whether that will be X or Y, away from the player, with a little bit of randomized thing here. So it's 2,000 plus minus whatever is in here in 800. So there's a little bit of variation of the distances that they actually do spawn on. Not that it matters too much because you don't actually see them off screen, but it's nice to have the option that I can just make them randomly spawn in different distances. So in here, we actually grab that spawn distance and we randomize that offset in here. We grab the offset, which multiplies by the random, so we get up to values up to 800, and we pick any values from there, so it does spawn at any distance in here. And over here, just like how we did with the spawns, we did something similar with the random. If I get anything above 0.5 or anything less, we get -1 or we get 1. And this is for me to grab on and multiply into the place where we're going to spawn these enemies, right over here. This is because they could spawn from up, and which is -y, or they could spawn down, which is y. Same thing for x, -x, or positive x. If I did not have this random site over here, they will only spawn down or they will only spawn to the right. So that's why I needed that over here. This over here gave me a lot of issues, and that was the synchronizing of the enemies. A lot of the times when I was creating and drawing enemies or just killing or just doing things to an enemy, whether I'm accessing an enemy in here, we will get a concurrent modification error, which basically meant that the AWT, I think it's called, thread, was trying to modify an enemy at the same time as something else was modifying it. So I might be drawing it while something is trying to kill it or spawn it or whatever it is. Synchronizing here helps, so they kind of like so they avoid doing the same thing to it, but it does delay things, and it can be pretty intensive because you're basically making that thread wait. But it's kind of necessary for spawning enemies in here. Otherwise, there will be a lot of errors in here. You can see this synchronized uh, thing be sprinkled in across different things over here that have to do with enemies, and they kind of have kept concurrent modification errors in check somewhat. I haven't seen one in a while, and they haven't popped up for this demo that we did. But we after we spawn these enemies over here, let's go back up, and this is how we establish our parallax scrolling. We have our screen width and our screen height divided by 2, which is the screens over there that we established up there in the files. It's somewhere over here. No, it's sorry, it's in the game base. But you saw it back there that right over here that we establish our resolutions in here. Every single time we have methods that refer to our monitor, I just refer to this rather than writing my resolution. Right now, my monitor is at 1440p. So if your monitor is at 1080p, I'd suggest you change this. Of course, you know this, but this is for me to establish my cam X and my cam Y for parallax scrolling. If we go further down, at the beginning of the game, I also want to establish that the player moving is false, and this will be useful for poses. Then over here, let me just see how the recording is looking. Okay. So now we have our weapons over here, and we have so over here we change our directions depending on the on the uh, on the keys that we're pressing. Using that key listener, we want to go to the left by a speed of 6. We use this Go LT, which is in the Sprite class, I believe. These allow us, and again, this chunk is code that we learned in class. They allow us to move, and I believe the word that you used was asynchronously. But more importantly, they trigger our moving flags, and they trigger our current poses in here. And this is used to actually check the direction in which our weapons are actually aiming, and trigger our moving flags, which is something that you would need for animations over here. That I will go more into detail in a moment. But we have the 3 different types of weapons, and that's our arrows, which is our bow, our axe, and our sword over here. And they all behave quite differently. And I need to establish what the lock poles are for these two. So basically, the way that the bows and the axe work is that while they're in midair, I want to lock in into the direction that they're traveling in. Because if I don't do that, and let's say that I have an arrow that's traveling up, and it's currently midair, and my character suddenly decides to turn left, I don't want that arrow to go to the left. I want it to stay up. These variables, you will see them again down there, allow me to lock in into that position. The sword, however, you can see that I use current pulsing here because it is used differently for the swords, and that's because the swords doesn't matter which direction you're choosing. If you are currently in a sword animation facing to the right side, doesn't matter if you turn to the left side, that's fine. If the slashes do move for an arrow, that matters a whole lot because you're doing this in midair. But we do this for each cardinal direction, and we locked in its position for each one of these weapons. We'll see more about that down there, but that's just for establishing the directions at the moment. For the enemies, I made a enhanced loop in here, and this is something that you will frequently see through my code, which is quite useful because I use this to see a variety of things on the enemies, whether that's to I don't know, make him lose health, or check on their collisions, or do anything that has me to check what a particular enemy is doing. I can refer to all of them. I can refer to them as enemy using this. So if I wanted to see if there's a particular enemy that's, I don't know, touching me, I can just call an enemy, and this enhanced loop will be able to apply a variety of things to all the enemies for me. So for example, if I'm again dealing damage to an enemy, if my sword is overlapping with something that's an enemy, take health away from that enemy. So this is something that you will see sprinkle across my code when it comes to dealing with a huge amount of things that have some kind of shared behavior going on. So the enemies do usually start not moving, and I use the chase method, so they're constantly chasing the player at a speed of 3. Uh, they kind of use the same logic in terms of moving as the player. Uh, if the enemy is moving up, which is shown with the chase method, it's uh, if it's moving up, we switch our poses to up. So we can actually see the up sprite of the enemy. And we do the same for down, left, and right. We can go and look at the rect class once more, where it's right here. So we saw our rect class over here. That's basically what we use for our chase. Uh, the give me a second. Oh, I'm in the wrong class over here. But basically, when we are moving, I was trying to remember whether I had make a method for this or it was just an attribute. I did forget, but because it was a while ago that I didn't make this. Uh, but you notice that each one of these flags do trigger a moving up or moving down or moving left or moving right flag. Each one of these, when I'm chasing or not, they, for example, over here, if we use our logic for chase, which means that the x for this particular object is greater than the object passed in, well, it's actually moving to the left. So I have all these flags triggered in, so I can actually refer back to the enemy, to the animation class, and use the correct posing here. This pose, that's how we get the correct sprite. If they're chasing us up, we set their pose to be up, which is used by the animation class to show their up sprite. All the sprites are name verbs in a similar syntax from the animation class that we had used before. So we have 4 sprites for each one of the enemies and 4 sprites for the player. We do not have the same though for the swords and the bowls and the axe, because for those they're not drawn to be up, down, left, right. You can just grab one position and just mirror it over the cardinal directions. But that's that for that. And now we have for the damage. So again, I mentioned how I use the enemies for the enhanced loops. This is a little bit different. I want to use an iterator. And the reason is because the iterator in here will allow me to remove enemies without worrying about node checks in here. If I had used the enhanced loop over there, and I just declare my enemy as null, often I will get crashes. So a safer way for me to do that is to use the dat remove uh, method from the iterator. And you can see this right underneath this, that without if our enemy at some point reaches 0 health or below, doing a couple things. There's a less than, we decrement the enemy count, we increment our kills, and we increment our total kills. We also gained the XP from that particular enemy. It's actually helpful if I show you the enemy class right now. Each one of the enemies has an enemy XP. And that's how we gain XP. You saw them passed in for the skeletons. So that particular enemy will give us that amount of XP into our character. But this is functionally very similar to the player class, which I might as well just show you right now. It's functionally almost the same. The only difference is really that we do have our last time hit volume, which we used to, if you when you saw into the demo, we can only get hit every second. This is used for that. Uh, and we also have our string with the pulses in here, which is just the counting of the directions, and we have the different stats passed in. We have our x and our y. We have our widths. We have our the pulses that we have in here. We have the this is the super method from Sprite. I might as well just show you the Sprite. So we have our count, which is the number of frames that we have in our class, and we have the duration of those frames. For the player, we have 3 frames, which is just 3 pictures for each. The same thing for the enemies. They all have just 3 frames looping back and forth. And there's a size offset when for the sprites. So I guess we'll go over the sprite class too. So we have our ints for each one of the positions, which is picked later on in the animation class. So we can establish an array. This is because you would see, again, this is stuff that we have taken for class, but this will represent 0, this will represent 1, 2, and 3 because it's an array of size 4. That's the reason why we have these numbers set up in here. There's an offset that I have made in here because if some of the sprites, the rectangle boxes were a little bit too big, so it seemed like you were hitting things in the air and still registering a collision when you think it shouldn't be. This is just to visually accommodate for that a little bit, so the player is fitted a little bit more tightly into the rectangle that the rectangle class makes. But we do make our animations in here. Uh, and we do set up grabbing the name of the object that we made in here, because we do grab each one of these names. Same thing in here. When we went back into the game.java, we passed in. I mean, you saw this already. We have passed in skeleton or skeleton red eye or red skeleton. We pass in basically just the name of the string in here. As you can see in here, for example, we have player, and we have our pose in here, and and this is for creating the amount of frames that we have and the duration. Then we have our draw methods. This snippet is still something that we had gotten from class, but I did adjust in here what I was saying earlier for the offset. I adjusted the width to be 50, and I adjusted the height to be the same offset in here. I think I can easily just put offset in here. I think I just forgot to change it into size offset in here. I'll probably just change that later, but these are still the same. This is just a size offset. I made it wide plus 50 and tall plus 50 just so they're a little bit neater into the rectangle boxes in here. For the animation class, and I think this is the last bit of the classes that are similar to the stuff that we did in class. We passed in here, we get our images from each one. When we pass in the count, we iterate to that count and we get the names. So we get player, what is it, 0, 1, 2, that PNG. That's how we get these. And for the next images, we start, we move up for each image. If it's a still image, we stay at 0, such as in walking versus standing up. Again, this is a snippet from coding class, but I believe this is the last bit from the stuff that we learned in class. I did make some modifications of this class for the weapons because they do act quite differently than just the player sprites. So I made a weapon animation.java and I made a weapon sprite.java, and these are different because I animate this differently than the players. So There's a couple of variables in here for weapon animation, and that is we still keep our current, we still keep our durations in here and the number of frames. Um, Frame times, something that will be used later on, and loopable. Some weapons are fine to be looped, some weapons aren't. So for example, the sword, which is comprised of 9 frames, I want the sword animation to to stop on the 9th frame. I don't want it to loop back and forth. The arrows and the axes, however, uh, when the arrow is mid-air, I still want it to keep animated, and I don't want it to disappear by the 4th frame. I want it to loop around on these. And that's what the loopable flag is, and these will be triggered by the creation of the respective weapon in there. So, just like the animation class, we get our each one of our images with a name and iterating through them. Then we have our durations, number of frames, whether it's loopable or not, and our frame time, grabbing our system, the time from our system, which so we can use this and later on animate the weapons correctly with them. You will see more about those later. But so the things are done differently in here is 2 things. So we do grab some of the time in here, and over here we use the time now that we created using the system time minus the last frame time. So the last frame time is the time that was grabbed at the particular moment that frame happened. And now, since it just got updated at this current time, it allows me to grab how much time has happened ever since the last frame. If that's greater than the duration, meaning, for example, 14 frames have passed since the last time I did a frame, well, that means that the animation for this weapon is over. That's what this is for. We increment in here our current in order to move into the next frame, and we just update the time that the frame just happened, which is now, as we just advance into the next frame. And at some point at the end, we have to make a decision what we do at the end. So if something is loopable, we want to stay on the last frame. Why did I bring this over here? So wait, this comments are not correct. But what's going on in here is that if our weapon is loopable in here, we go back to the first frame and we just go and play this over and over again. So if it's 4 frames, when we're on our 4th frame, which is indicated by the image length in here, the array that we made in here, let's go back to 1 and let's go over those images again. And then we reach the end, we go back to 1. This is what it means by loopable. I should change this comment here. Now over here, if else, we stay on the last frame, which is the very last frame of the image length. So if I'm on frame 4, let's stay in frame 4. That's what's going to happen in here. And we return our image as a result of all this. Reset over here helps us to reset animations by setting the current frame to the very first one over here. And once again, we grab the last time that we grabbed the frame over here, which is used for the resets in here. So that's the difference for the weapon animation. Let me actually just save that. Weapon sprite, even more differences in here. So we do still have each one of these. Let me just see how much time it has had. Okay. We do still grab each one of these numbers for calling the arrays for each one of the positions in here. And we use the same way that we declare each one of these weapons in here, including the loopable one, now that you have seen how that works. But now we have to draw this, and this is something I had to look up. So remember what I said earlier about that some of the weapons, all the weapons, I do not need to treat them as the sprites on the players, because each sprite up, down, left, right have different sprites, but for the weapons, they only really have been drawn for the right sprites, and I can just mirror that. This is where graphics 2D comes in handy. So I can grab that image and I can do things to it. I can mirror them, I can rotate them, and that's how I get up, down, left from just a right sprite over here. So we have our 4 positions in here. If we are in our right position, we can just draw this as this. Plus the offset, the size offset that I mentioned earlier to make the hitboxes look a little bit neater. Sorry. If it's facing the right side, we can just leave it as is, because most of these sprites, actually no, all of these sprites were designed to be facing to the right side, so we just leave it as is. If we're facing the left side, by the way, every single time we're drawing, we are subtracting with cam X and cam Y for parallax scrolling, so these actually do make sense. Some things do have to be drawn X to Y relatively to the world rather than the camera, but since we're talking about sprites in here, we are using cam X and cam Y, so this is going to be used a lot in here. So in here, let's go to the left. We want to draw this in X, but we also want to draw this on the left side. So what do? We grab the width of the sprite and we add it on. The mirroring that happens over here happens right over here where we invert the W, the width. We're giving it negative width, which makes it mirror horizontally. The reason why we add this over here too is to offset for that mirroring that we're doing, so we're moving it a little bit closer to the catcher. That's why we add the W in here, since we are mirroring this in negative W. For up and down, not only do we have to do this, which is pretty easy to do without G2D, now we actually need to translate and rotate the images. This is where G2D actually comes in handy. So we do something similar with the W in here in order to offset for the rotation that we're going to do, that we're adding the width back. This is going to go towards the center. And then we use the rotate method for G2D. So we can rotate them into an angle of 90 degrees. Well, negative 90 degrees, because I wanted to face it up. Now we draw the image. We draw the image in here and we do something similar with the W to offset the distance that it has traveled from the center into the character by using the width. And we reset them back into their old form. Down takes a very similar spin on this. The same thing is the only thing really is that we just rotate by positive 90 degrees instead. But we use our sprite offsets overall, and this is really just geometrically trying to manipulate these objects as we draw them. Every single one of the weapons basically use this, up, down, and right. But that's for the weapon sprite. That's pretty much it that's going on in there. But let's go back into our main class over here. What's going on in here? Alright, so where were we last time? So I'm not sure if we actually went over this at the beginning, but there is a song that I've been playing at the beginning of the loop. I did not think I actually went over this, but there is a there is a song that I play towards the beginning of the game, and that's though the sound effects that we listen to, it comes from the sound player class over here, which I'm using the audio input stream that Java comes with to put in a clip of audio in that WAV that I can use to add sound to the game. And the thing is that I need to make two of these objects because one of them is handling sound effects and the other one is handling the actual sound. I think I mentioned that during the actual demo of the game. And the reason behind that is because you want the music to play without no interruptions. You just want the music to keep going. So for that to happen, you need to grab the audio file, play through the object that this Java library makes, but you do not want it to overlap. So you have to check on whether this clip is running, and of course, no check because why not? You have to check for any overlapping here because if you don't, then when it starts playing, it will just resume that sound and it will just do that every single frame. It will start playing that sound again and again and again. And none of the instances where it starts playing, it will not stop. And that will make your game crash and it will not sound very pretty. So you have this playing the music constantly in the back, while you have this handling the individual sounds that the game will play. And you can see me calling for each one of these when something happens that requires sound. So right over here, oh, by the way, removing them safely, that's what I mentioned before. But right over here, I made a hit sound, so if I get hit, you play a sound, and that's where we call our sound player in here. Towards the beginning, I'm pretty sure I did start the song. I just can't really see where it is. I'll just look it up later. But somewhere in the beginning of there, I have exactly this, just playing the play music with my WAV file. So this is when I get hit, and over here, this is the variables I grabbed time since last hit. That was established later on the last time that I was hit. Over here is where established. So when I get hit, this gets refreshed, and I compare the current time to that to see if enough time has happened in between that. I play my sound, and I lose as much health as is equal to the enemy strength over here. When that happens, I enable this attribute called flash red that I had put into player over here, and I add the current time plus 200. What this does is that little decal that you see, that is the hit indicator, I will play that for 200 milliseconds to visually see that I'm getting hit. The same thing will happen to the enemies, and you will see this exact same logic going on in there. And once enough time has passed, I set that to false, so it turns off. Now, this is for wall collisions. Every single time that I go into a wall, and this is where I use the came from above and came from whatever other direction methods from rec, I get pushed by the same speed that the player goes into, so I don't go past them. And this is where the overlap method comes in handy. But what about walls? So when we created our tiles, it's somewhere in the drawer method. Just give me a second. Right over here. So this is where I make my tiles, and it's a very similar method to how we did it in class when making tiles. In here we're iterating through the map, the huge string of maps over there, and we're grabbing each one of these characters. We filled that square with A's, W's, B's, and C's. A's are our regular tiles in here that we draw to the specified size using cam X and cam Y. and using the positions J and I. For this is for parallax scrolling, just the position, so we can put them in a grid-like pattern. This is the regular tiles. This over here, the W's are the walls. Now we did that every single time that we built these walls, assuming they have not been built, meaning that this loop hasn't ended, like right over here as it indicates. If that loop hasn't ended, then the walls haven't been built. Add each one of these walls into this list over here that I can refer to later in order for me to just make them into rectangle objects I cannot actually overlap. B's over here, some other type of tile. C's over here, some other type of tile. I think those are the crates, and these are the tiles that have slightly broken pieces in them. Once this loop ends, we get our walls built. But let's go back up to where we were. So enemy collision. This is an interesting one because what we did over here is that we check for collisions going on over here. This is tracking how many collision checks we have done at every frame. And I want to do collision checks every 30 seconds. The reason why I'm doing this is because this is pretty expensive to do. This is a double loop. I'm checking for my first enemy, I'm checking for my second enemy, and I'm seeing if enemy 1 and enemy 2 are overlapping. I mentioned this in my notes, that there is way better ways of going about this, but this is how I went with right now. This is a double loop that's running at all to the second speeds, and it can be pretty pricey. So I am checking for enemy 1 if it's overlapping for enemy 2. The second loop will check for that enemy 2 over here. And well, I'm checking if it's coming from above, below, left, and right. And if that's so, I'm gonna push it by around 8. I thought that was a speed that was high enough to like counteract the speeds of like both of them coming up at once. This basically adds up to 16. It looks pretty alright for what it is, but it can get pretty slippery if you when you saw in the demo. Now, there are smoother ways of dealing with this, and one of them was through damping, which is something I have yet to implement, of course. If I wanted to do that, I would, implement damping, but this is a pretty expensive method to do. So I'm only doing this every 30 frames because I figured I'm already pushing them for it so much. Let me just do that every 30 frames instead. And it works out just fine. If I was doing this every single frame without this check going on in here, I'm doing this double loop at every single frame for whatever amount of enemies I have in there. It can lag the game quite a lot. In my notes, I did write this, but one way that this actually can become a whole lot less expensive is using quad spacing, collisioning, something like that. I can't remember, but basically is instead of me checking for each one of his enemies one by one to see if they're colliding, I'm checking bigger groups of enemies. So I'm checking quadrants basically of clusters of enemies and see if those clusters overlap with each other. And then check those individual members of those clusters to see if any of those overlap with the enemies. So that's one way that you can optimize this by quite a lot, but it is not something I have yet done. But so far, me delaying the collision checks by 30 frames, it's serviceable enough right now. So now we have our damage checks in here. And now over here, this over here is for us to be able to mirror our sword to left, down, right, up. So we had made our weapon sprites with the animations and the weapon animation, the weapon sprite actually animate the image by rotating it over. This actually turns some of the weapons in here. So over here, if our position is to the right, we're positioning our sword X plus W, our width. I'm moving it a little bit. For the our Y, it's just going to grab our player's Y over here, and we change the widths of the sword right over here, and that's to alter a little bit whether we're looking up or down. Kind of make it look narrower if we're looking up. visually it can look a little bit different. I think I should change it back to just be symmetrical, but it does make it narrower when we look up and down. But this, for example, down here, I'm making it y minus 200. It positions the sword down. So that's cardinally, it just adjusts the position for, so it ends up in front of the player. For the damage check itself, if I check that any of the hitboxes for the sword or the uh, overlaps or contains any enemy at their position, take their health out. Take their health minus the strength. That's what they're getting. Now with strength for the weapon I think is 15, so effectively they lose 15 health. And when that happens, we get to play our hit sound from the sound object that we have in our class over here. Now we make the enemy flash red and we add a duration to the flash red just like how we did the player. So we can then play the our hits, which is these threes over here. Now for the bows were very painful to animate in here, and so were axes. And what happened in here is that we have to set a variety of timers. So we have to check whatever that, and we did the same thing over here. This is for when the sword is animated. We have to make checks to do these things when the sword is animating. Over here we have to check if both the bow is animating, if there's an arrow currently in midair. So we grab the current time and we check if it's greater than the position timer over here. If it is, then we're going to reset basically that timer, grabbing the bow animation end time over here, which is into where's my bow? So for the bows, you have different things going on in here. You have the number of frames, which is 4 sprites that we have here. We have our strength. We have our delay, which directly impacts how often we can get out that bow. We have our pulses, just like how we did with the other ones, with the player sprites. And we have this Vx and Vy variables that control our velocity when the arrow is midair. Our midair variable is in here. This is the time that has passed for since firing, and this is the time that it lasts in midair, usually tied to the weapon delay. And this is where we locked our pose. The axe has basically the exact same logic, just adjusted to the axe. Notice that this is a double, and you will see this later. So down here, given that the bow is animated and the bow is not midair, we're going to now set the bow to midair because it means we just fired it. Our fire time is now, so that's why we declare this as current time. And it has been 0 frames because we just fired it now. So we want to lock in the bow, the current position that we have in the bow, to the current position, to the pose, the current pose, to the current pose that the player has, so we can lock it in there. And not have it change in midair. This is only refresh every single time that this block runs. So if I'm shooting an arrow to the left, I don't want it to change to the right side when I decide to turn to the right side when the arrow is in midair. So over here we do some adjustments for X and Y, just like how we did with the sword, to position the arrows correctly. And we do add some velocities depending on which direction we're going. This is probably the more important part of the bows in here, because if I'm facing to the right side, I am moving Vx6. I'm moving to the right side. If I'm on the left side, -6 on the X. -6 on the Y if it's up, and 6 if I'm going down on the Y. Now, if the bow is midair, meaning that I just fired it, if at some point, this whole block is what executes in when it's in midair. If at some point the timer runs down using the fire time and the current time, we set this bow back to false, so we can go back and re-execute our bow logic. What's over here? This over here was previously put on because I wanted to delay how fast the ball comes out. The problem with what was happening before with my code is that I was running on a laptop that would get frame drops. And when I would get a frame drop, the projectiles will be very, very fast. So this was a way for me to kind of delay how fast they were going by just incrementing the speeds at different frames rather than at each frame. I no longer need this right now because I'm satisfied with the speeds right now. But I did something, a better fix later on with the axe, and you will see this later. But we move the x by the bx, and we move the y by the by. The speeds that we have been building up in there. Uh, and we do count the frames that we have fired. We no longer need this though, because I just said how we don't need it at all. So we really just don't need this. I was just left over from here. Uh, and our damage calculation is very similar to the sword. We take the strength of the bow, uh, the health in here. They lose as much health in terms of the strength of the bow, which is somewhere around 15 or 20. I can't remember right now. They lose 15 health every single time that the bow goes through them. And if the time has elapsed, that if the time is greater than the ball animation time that we have established down there, based on the current time plus the delay set by the ball, it's no longer animating. And now we are free to go back into this block and do everything in there because we are no longer midair and and we are not animating. We are not no longer animating. Actually, hold on. Just give me a second. I cannot remember where it is, but this is actually not for up there because this is for the drawing method. You will see this later, the bow animated method. Uh, but over here in the X, we do a very similar um we do a very similar logic in here. It's literally the exact same thing as the bow. The only difference is that we do have a little bit of a speed in here, and that's negative 18, and that's so we go up in an arc. I want the X to kind of travel in an arc across the screen, so we start at a velocity of negative 18. Over time, though, we increment the speed by 0.2, so it slowly starts to go down. Although it's still very rapid, the current way that it's set up, but it does kind of go in a little arc across the screen, which is still kind of helpful. Uh, this can increment though extremely rapidly, so I capped it so it only goes to 5. So if it goes anything beyond 5, it will just set itself back to 5 because it can. This happens every single frame. It can go past 5 extremely quickly. This will happen in a single second. I'm already incremented this 60 times, so I do need a cap of some sort in order to make the X not fly off the screen. I should probably make this slower to be honest. And we have our overlapping here. I take the health based on their strength, and if enough time has elapsed, I get our we get our animating flags to be false in here. Uh, now, give me a second. Huh, alright. Just seeing how much time we have. Wait, where am I? Okay, so we get our animating to be false in here, and lastly, we get our level check. So every single time that we kill our enemies, uh, we want to trigger the level up screen that we did. When we get past the amount of XP that's over here, we want to trigger the level up method that we have in here, and we set the XP back to 0, so we can go back and increment into 1,000 while we go up a level, and we turn up the level up waiting screen, the voting I mean, so we can trigger that screen that we saw at the end. At the end, however, we always make this check to see if the player is dead or not, and we made it null. This can be kind of unsafe, and I think a better way to have this on, instead of doing this, is for me to just play a death animation and just block all the movement, block the keys, so we no longer receive input, and play the game over screen over here. So, I think I went through these already. Hold on. So I went through these. What have I not gone over here? So over here, we draw our character with our pen and camera X and camera Y to account for parallax scrolling. And this is another place where I mentioned that we have to synchronize our enemies, because I don't want to be drawing them when there's something else happening to them. So when I don't have this, I get a lot of concurrent modification errors in here. So that's the reason why that's here. And remember what I said about the iterators. So the has enhanced loops. So we can actually refer to all these enemies at once. That's how we did with the damage up there, and this is how we're doing to draw the healths over here. So given that they're not null, we're drawing them. Now we have our enemy healths, the health bars that they have on top. And this is something that I need to adjust, because when we had our health bars up there, you would notice that the health bars were getting longer, and they overlap the black background that they had. This is because of the amount of health that they were getting that was over the max health. So if you see here, if we establish a width and we establish a height just to draw it later on, and we place the X and Y using cam X and cam Y for parallax scrolling, this is just little visual adjustment to make them a little bit more adjusted to the sprite. Same thing with the offsetting here, but we want the X, we want them to be around the center of the sprite. So that's usually why we grab the W. If we grab their width and we divide it by 2, we're going to be right in the middle of the enemy. We also divided that offset by 2 because our offset was 50. So we're dividing that same offset by 2 just to accommodate for that. And the same thing happens here with the width. We set the background color to gray. We grab our X, we grab our Y. When we basically make this bar that's behind the red bar, using it should be the same size, but these are actually set up to be a representation of their max health. When you have over here, hold on, over here we're gonna actually fill this bar with red. So we already have put our height, our width, that's just going to basically where our bar is going to be contained. Now let's actually fill it with red, and red is actually going to be a ratio between their health and their max health. So it's only going to decrease in proportion to how much health they have to the max health. So if I have 50 health out of 100, the bar should be somewhere in the middle. That's why we are dividing it here. And the way that this is going to look is that you'll see that the health bar is just going to keep going down with a background that's black over it. And of course, we're doing this as wide as the bar width. We did the same thing with the XP bar in here. We will grab we will put a certain width and height, and we will center it using those same attributes. It's the exact same way that we set up the health bar. But instead of using max health, and so we're actually making it as a proportion of XP and the scaled up XP needed, which is basically the max XP that you need for that instance. So that's how we make the XP bar work. Player health is the exact same, except that well, it's not the exact same. Sorry, I'm thinking of my group project where I actually did bar for the health, but in this game we are actually doing a numeric value. So all we're doing is just printing HP on the top left, the X and Y's in here, and we're just grabbing the player health and just printing it in there. The timer, we just grab this is all using our drawstring methods, if you noticed already. But the timer, we just grabbing the time in seconds and just putting it in the middle of the screen with the width in here, with some Y added in there. And our round numbers, the same thing, but we are grabbing the round number, printed it in there. And I kind of want it to be somewhere in the end of the screen. I don't want this to be a static number, because otherwise it can just go off screen. So I want to be this relative to the width of the screen that you're currently using for the resolution. Level, same thing. Total kills, exact same thing again, just different positions on in the X and the Y's. And for here, this is the damage that we actually do, the damage indicators. So I'm actually supposed to be able to get a math random in here that gives me a value between these numbers over here. So I'm supposed to get each one of these. However, the way that it happened is that I will get all these three values randomly, and you can see here that I'm drawing the hit picture depending on whether it's 0, 1, 2, adjusted to the cam X and cam Y. So it's centered around the player. I did mess with the X and Y's in here to center somewhere around the player. And the thing is that while there was a delay on how much damage the player can take, it seemed like either the math random, or it was either the amount of times that the player would overlap but not necessarily take damage actually makes all the three wounds appear at once and kind of flash. I did voluntarily, however, decide to leave it like that because I thought I liked the visual effect that I left off. And the same thing happens to the enemies in here. The exact same thing, the only thing is that we're actually doing it over in the has loop in here. Now, so now in here, we have our soar animating, which is one of the variables that we were talking about before, and the same thing with bows, where we have bows animating or not. So those checks that were made before for the bow animating, that's what this is for right over here. So for swords, and they're kind of drawn like in the same way. If the sword is active over here, we actually start drawing it. If our current time happens to be bigger than our activation timer and our delay, which were attributes as shown before, we actually get to play a sound. And we want those frames to be set back to 0 and set this to animated to true so we can actually start working towards the animations in the weapon animation class. And here we set our animation end time to be the current time plus the frames that we have here. So this will be like current time plus 9 frames. And then our animation duration in here. The timer will be set to the current timing here. And then we get to actually draw in the sword in here using cam X and cam Y, so we can actually offset them to the cam X and cam Y variables for parallax scrolling. Same thing will happen with the bow. and once enough time has passed, when the animation has ended, we set it to false, so we actually stop animating this thing. Balls are not pretty similar, but pretty much the same thing. It's the same logic going on in here, and the same thing for the axis. They do have their same, they have their unique sounds in here that are played through that class. Um, Lastly, towards the end of this class, we have our game over. So when your player health reaches 0, we trigger this game over flag in here somewhere out there, and if that's true, then we draw on the screen game over, and we grab the different things that I've showed on the screen in there. So we set our rectangle in here, grabbing our width and our height of our current monitor, and we set our font, we set our color to white, and this is what I wrote on the screen. I want it to be in the middle of the screen, so width divided by 2. And we wrote game over. We wrote do that on round whatever it is. We have a string in here, and we grab the value of round number. Although I believe I could just grab the round number itself, or it might be just a drawstring, but I could have just done it either way. Um, Same thing that we did to and took down. I will display the amount of enemies that we killed in total. And this is to some extra strength, because when I drew this up here over here, it will cut off and go too much to the right. So I wrote this in the new line. So you can see me changing the Y values to represent that. And I also want these all to be in the middle. And this is the last part of the game class, which is the bulk of this whole game. This is where we did our tiles, I think we did before. And this is where we did our start time. This is where we converted into seconds, because we divided by 1,000. In here, we actually create our weapons. We create them and we put them relative to the player position, and we set their frames, and we set whether they're loopable or not. You can see that this is not loopable, and you can see that the balls and the axis are loopable. We add these into the list, in the weapons list, so we can control what each one of these weapons does. Like for example, when we were talking about if the weapon is name is equals to arrow or axe, this is how we can refer to those things, and this is the same thing that we did with the enemies. What else have I not gone over? We went through this whole thing. This is the last class I think we have not gone over one. That's the camera class in here. So we set our camera locations to be the X and the Y that we passed uh, that we pass somewhere in the game Java in here, which is relative to our screen width and height. And every single time we move left, we move the camera. So we enable left, right, up and down. We move the camera so we can enable parallax scrolling, which is still more code that we had learned about in class. But this enables our parallax scrolling to pretty much work. I'm pretty sure that's it in terms of the project of what was going on in here. Let me just check if I can actually find that music that I was talking about in here, and that's actually right over here. There it is. Uh, so I just played this towards the beginning of the level. So this is playing exactly when the game loop starts, and this is just goes over and over and over again. This is the one thing I skipped in here, but overall, there's a lot going on in here, and you can see that there's so much that can be moved over into different classes. I just haven't really had the time to. Uh, and there's a couple of issues, however. Like for example, the axe Uh, it could be slower for sure. I could implement different things to make the drop more realistic. Definitely could add more tiles, actually beautify the game to add menus and whatnot. Uh, I have all the sprites I can adding into here. I haven't, as I mentioned before, I haven't completed the weapon system and the item system going on in here. But there's a lot of changes I can do, and a lot of them are optimization based. I actually am hoping to port this to C sharp at some point to see if, how much I can improve this by. Uh, but aside from that, there's not much else I can do except for just improvements on this and add an actual character selection screen. Uh, but so far, that's pretty much it for this game, and I hope you get to enjoy playing a little bit more if you get to. Well, that was it pretty much for my presentation. If you have any questions, do let me know. Thank you very much for watching this whole hour of me going through this game.